Hello! You may now have seen in a couple of videos that strange contraption that I took to the Amiga Kickstart event, and I've also taken it to RMC the Cave. Well, in this video I'm going to show you what it is and how it works. Ironically, it's actually all Neil from RMC's fault. He'd contacted me about archiving some discs using greaseweazle for a video he was making, and I commented that I actually had 3 of them. So why have I got 3? Well, I bought the first one to start building the floppy bridge plugin for WinUAE. But then I found it didn't support disk change, so I purchased a second one. More recently, someone was having a strange issue with WinUAE, so I obtained the greaseweazle version 4. Turned out to be user error, but now I had 3. Anyway, I decided to randomly message Ravi, who was the organiser of the event, and I said to him, I've probably got enough kit to help people back up floppy disks, and before I knew it, I was suddenly going to be running a disk backup service at the event. I thought to myself, well, if I'm gonna do this, I might as well make it look good. Oh, and before you ask, the reason I didn't use drawbridge was because I hadn't got any spare ones lying around. The first thing I needed was a suitable screen. Originally, I was just going to use an LCD monitor, but that's boring. I wanted something that could fit under the 3 drives so that 3 discs could be backed up at once. Well, there's screens designed like this to actually sit on the edge of shelves in shops, and lucky me, I work for a digital signage company and we have some lying around, so I borrowed one. What a perfect start! So, next I needed to build something to hold the floppy disk drives, as well as the USB ports and some buttons to control it all with. So I got designing and started printing out some parts. It took a while, as you'd imagine, there's quite a bit to print. I designed a box to house each floppy drive along with holes either side. I didn't want to print using support materials, so I printed pieces and glued them together. I also printed supports and arms so that each of the 3 drives could be lifted up in case I needed to service them. The great thing about designing 3D printed parts is you can get an idea of what it's going to look like before you print it. So on to the software. Well, there's 2 parts. First I want to control all of those buttons, and this is the easy bit. All I needed to do was to find an Arduino and wire the red and green buttons to it. The buttons already have resistors inside for the LEDs, so I didn't need to add any. I connected the Arduino to a small piece of strip board along with connectors, and ran the connections out to each of the 6 buttons. Now onto the code for the Arduino, which I bashed out pretty quickly, and based on where the connectors appeared on the board I defined the pins for the buttons and the LEDs, along with a structure to hold the current state of each button, which in a setup function I initialised ready for use. You can see here that I assigned A to C for the red button presses, D to F for the green buttons, and then G to L for the red and green long presses. Now I didn't just want the LEDs to flash, I wanted them to fade in and out smoothly. This makes them look a bit more like incandescent bulbs. Now normally you'd do this with the PWM outputs on the Arduino, but I need 6, so I've coded them manually. All this code is doing is counting up and down from 0 to 255, and then setting flash mode to true or false depending on if the counter is past a certain point. This section is handling data received from the PC with an @ symbol being used to signal the start of the control sequence, which is then immediately followed by 6 characters set to 0, 1 or 2 for the different modes. Yes, this could have been transmitted shorter using binary, but this is easier to debug. This line controls the LEDs of the buttons. Yeah, it's a little crazy, but essentially it turns the LED on, off or flashing depending on the current mode. If one of the buttons is pressed and hasn't been triggered yet, we know that this has happened, and then send a message back to the PC to inform it of the selection. If you hold the button down for 1.5 seconds, it performs a similar action and sends a special message to the PC. Finally, if the button isn't pressed and it's been more than 200 milliseconds, we reset the trigger flag. This is a crude but effective way to debounce the buttons. So let's take a look at that in action. Now I've got the system on the left and the Arduino interface on the right. Sending an exclamation mark gives us a Z back. This helps us identify it. Sending all zeros switches them off. Sending all ones makes them flash, and sending all twos turns them on statically. And with various combinations you can set different lights to come up in different ways. Pressing buttons also outputs the characters we expected back to the serial monitor. With that done, it was on to the rest of the software. Now the first part I needed to be able to do was identify which greaseweazle was connected to which COM port. I could manually set this up, but I did want this to be automatic. I connected all 3 greaseweazles up to a powered USB 3 hub, and, as luck would have it, by querying the right setup functions in Windows, you could find out what hub a COM port is connected to, and then which port within that hub, and they were literally numbered 1 to 4. Finding out which USB port a USB pen drive was plugged into, however, proved to be a lot more tricky. and I won't bore you with the details, but I eventually got that working after a lot of research, a lot of googling and a lot of digging. So that just led to the final part, the actual software. This strange screen has a resolution of 1920 pixels wide by 162 pixels tall. I already knew I wanted the user interface to have an Xcopy style to it, so I split the screen area into 3 sections, leaving some space for an advert for Retro Directory in the middle, and started designing. First, I painstakingly reworked the Retro Directory logo so that it followed the design style of the Xcopy logo. Not bad, eh? I then reworked the remaining parts of the Xcopy interface to fit the screen. Now it was time to work out the user experience, i.e. how a user would actually use the backup station, and I wanted it to be totally self-service and easy to use, with literally just a series of steps required when pressing the red or green buttons. And these are some of the messages that appear on the disk backup station when it's in use. With these designed, it was time to get on some coding. Now I usually write things like this in C++, but greaseweazle is written in Python. My drawbridge software can already create ADF files and SCP files. And as this is an Amiga show, this is all I would need. I also already had code in C++ to communicate with greaseweazle from my floppy bridge project. So by putting it all together, it resulted in a very user-friendly and simple to use backup system. Here you can see how I've designed this so I can lift each of the drives up individually so I can remove them if I need to. Of course you can lift all 3 sections, but then you get to see the messy wiring underneath. The only time I actually needed to intervene was to regularly clean the drives. After all, the state of some of these disks was going to be horrible. So I made sure I prepared myself and armed myself with some isopropanol alcohol, some distilled water, some homemade cleaning discs, and you can see how I made them in this video up here, and some cotton buds. Oh, and yes, it does make the famous Xcopy sound when the disk copy is complete. And it was quite successful and backed up and recovered about 30 discs during the weekend. I wasn't expecting it to be used a lot, but it did get used. Even to back up a disc that perhaps it shouldn't have, although it was all in good taste and a bit of fun. I even finally got to meet Keir Fraser, the creator of greaseweazle and the flash floppy firmware used by the Gotek drives. Of course the main reason I was there was to advertise Retro Directory, and if you don't know what that is, then check out this video. Now during the event, the main question I was asked when backing up to ADF was why does it say it was successful when you could clearly see there were some errors on track 80 and 81? Well, these aren't normally used on Amiga, especially with Amiga DOS disks. I decided to back them up anyway, just out of caution, but to not include them in the error reporting. And whilst we're talking about strange behaviours, no system would be complete without a few Easter eggs. And it appears the disk copy protector from the Don't Copy That Floppy video campaign would regularly appear to keep an eye on things whilst dancing along to his music. If you don't know who he is, then check out this video about copy protection. Mind you, one Easter egg is never enough, as Neil found out when I visited the cave recently with this randomly happening. One of the biggest issues I had when building this was the computer running it. I'd originally wanted to run it off an old Intel NUC PC, which seemed to work fine at first until I tried to back up 2 disks at the same time. Luckily, I had a laptop that was perfect for the task, and I'll be sharing some snippets of code from the project in the video description. At some point I may release a public version, but for now you'll just have to keep an eye on my channel. Keep an eye out also for the disk backup station at future retro events. I hope you found this interesting. Thanks for watching, and I'll see you in the next one.